So, next question is question 2 sub 2. So, that is f z to z given by f of x equal to x square. I am leaving this question for you to do because it is exactly like n, you try it out. Let me do the third one. Okay. So, question 2 number 3. So, question 2 number 3, what does it state? It state f from real to real. Okay. So, f is from real to real and f of x equals to f of x equal to x square. Okay. F of x equals to x square. So, check. So, first of all, as we know, if I make the solution table and plot the graph, I know I have already told you the graph of x square, as it is square, there will be no negative values. Hence, the graph will be something like, and there you see there is no, and there is no intercept also. As there is no intercept, the graph is something like this. Okay. So, now let us check, is it 1 1 or not? Injectivity check. Injectivity check. So, what do you see? If I draw a straight line, you can see every distinct value of y, for every distinct value of y, there is two values of x. That means, so the value, so the picture will be something like this. So, if this is y, there will be two values of x, like this and like this. So, the definition do not say that, it should be every x, it should be something like this, that every value of every x will have its distinct image y, right. So, if this is x 2, it should have y, here it is not having. So, here what is happening, for for all x 1 x 2 element of which portion of the range, definitely the real. So, R, there exists a single image y element of R. Hence, f of x is many one and not 1 1 function. So, that means this is injectivity check fails. Let us see for it for the surjectivity. So, this must be the plus, all the plus real numbers here, and this must be what, minus real numbers. So, how can we write? So, you can see this, all the minus number, the graph has no values for minus, right. As f of x equal to square, so there is no y, okay, no y element from where to where, no y element of, see how I write it, 0 to, this way also you can write 0 to minus infinity. So, close bracket means 0 is included, minus infinity is not included, 0 to infinity, but this is subset of what? Subset of real, right. There is no y element of this subset of R for which for y element of this there exists x. So, there is no x on this side, no. So, x again you can say element 0 to minus infinity, no, subset of real. Hence, because every element must be at least, every element, the definition of onto function says that every element of the codomain must be an image of at least one element of the domain. So, here what about the next portion? The graph is not present at all in this region, graph is not present in this region at all. So, this is what we are saying, try to understand it. From 0 to infinity, that means this is 0 and go to minus infinity, there is. So, for all the y values from 0 to infinity, there is no corresponding x from 0 to, so no, we can write, no, this is sorry, we could write this from r only, no need to write that, sorry, I just did one mistake. X element of r, x element of just real, see I was just doing a mistake here, y subset of 0 to minus infinity subset of real, there exists, there is no y for the x element of, because x element of the real, hence the function is not onto. Try to understand once again. So, what I mean to say, f of x is square, as it is square there will be no negative values, f of x will be never negative. Hence, how do I write this? So, you can see there is no y element from 0 to minus infinity, 0 to minus infinity, 0 to minus infinity y for all x element of r, right. So, there is no x for y, I think you have got it, hence the function is not onto. So, it is not a bijective also. Okay. See, once the fundamentals are clear, you can write the answer in different way, it is all up to you to answer it now, understand. And yes, definitely the curve will be continuous in the first two quadrant. So, there too it is not even 1 also, because it is minion. Now, if you change the domain, for example, if I change it, if they change the functions like this, from, if I change this, f of domain is r, however, codomain is from codomain will be, let us say, from 0 to plus infinity. Now, is the function now is the function onto? The function is now onto, because we have changed this. So, this is the domain, this is the codomain. Now, you can see I am talking only about this region, hence this function is now onto, because in this case now you can see, we can say y element of what, 0 to plus infinity, there exist x1 and x2 element of r, right. Hence, there exists x1 and x2 element of r, hence f r to 0 to infinity defined as f of x equals to x square is onto. See how we just manipulated domain and codomain, and the function becomes onto, but it is not even one, it is many one. Okay, and it is not bijective, don't forget, it is not bijective. Okay, can you make this bijective? Yes, you can make this bijective. How can you change it? Just change the domain. If I change the domain, f, I can change it from what to what, 0 to plus infinity, and this is also 0 to infinity. So, I am talking about this graph, I am talking about only this portion of the graph. Yeah, I am only talking about this portion of the graph. Can you see here? If I draw a straight line, there is 1 1, it's passed the test, correct, and it is onto also, because for every value of y there is a x within from the domain only. Hence, this function is bijective. This is bijective. Because this is 1 1, I leave this for you to prove it, 1 1 and onto. and this is bijective. Clear? I hope you have understood it.